I've always been motivated in my research by the goal of solving problems, what positive outcome could come if everything goes as we hope. And that's certainly been the case for our smart windows research. Smart windows dynamically control the solar radiation coming from sunlight and entering our buildings. And we want to control this dynamically to manage the heat loads that vary from season to season and from building type to building type. Smart windows can make the interior space more comfortable by allowing you to have an open interaction with the outdoors visually while minimizing the discomfort of having too much heat or not enough heat coming from the warmth of the sun. In warm climates, we generally want to reduce the heat load from the sun entering our spaces so we can minimize our need for air conditioning, while in colder climates, we might take advantage of solar heating to reduce our need for artificial heating of our interior space.
She has a very deep understanding of the chemistry and the physics of nanocrystals, which are really the functional components of the windows.
The kind of smart windows that we work on are electrochromic, meaning that we are able to control the sunlight by applying a variable voltage to a coating on the window. And that coating consists of the nanocrystals that we use chemistry to synthesize in the lab, and then we coat them from a solution onto the piece of glass. Metals normally reflect visible light. We've made materials that act like metals towards infrared light by introducing impurities in a very specific way. So it was really just an idea at the beginning that we could use nanocrystals to separate the control over visible and infrared light in an electrochromic window. And when we got the first data that showed we were able to modulate infrared light selectively, it was really exciting. That's what gave us the motivation and the excitement that maybe we could really make a technology out of this. I love doing this mostly because of what I see in the students. That's what this job is all about.
We're doing really good science, fundamental science right now in the labs, but at the end of the day, if we figured out these problems, can directly catalyze change in the real world.
I grew up tinkering. Anything that would break in the house was mine, and I got to take it apart and try to put it back together. I don't think I ever fixed anything, but I learned a lot. My mom was actually a professor when I was a kid, and my dad was an engineer designing superconducting magnets. It gave me a really big head start in approaching, the science that I do now.
Think about completely new architectural designs for industrial and residential homes.
Good architectural design and advancing these technologies of smart windows is really going to influence the buildings of the future. I don't know what the next big problem we're going to go after is. There will be opportunities I haven't yet dreamed of. It's incredibly exciting to be on the forefront of science. It's just thrilling.